want to record it, right?
Okay.
Okay, is that true?
That's true.
I'm going to help you remember that. Okay. So, step 1, use the chemical symbols for the various elements to write the skeletal structure of the compound. Okay, so they gave us NH4 plus and they said draw the Lewis structure. So I need to write the skeletal structure. In detail here, it says that the least electronegative atom will be placed in the center. But if you haven't talked about that yet, I'll tell you that whenever I go over, like whenever I do this, if I'm being really proper, then I'll look up in the electronegativity chart, which is the least electronegative. But usually what I do is this. Most of these structures are like flowers, like daisies. And so there's only 1 nitrogen and 4 hydrogens. So it's like nitrogen's the center of the daisy, and then the hydrogens are the petals. And that's how most of these go. It's like a flower, you know, a sunflower, a daisy. Okay. So there'll be like 1 of a certain element, and then 3 or 4 or maybe 2 of another element. And I'll just draw it around. But the proper way is to look up the least electronegative, and then you'd find out that it's nitrogen and draw the rest around it. Okay, I will say though, just to run through the other exceptions and stuff, hydrogen is always going to be it's going to occupy a terminal position, so that means one of the ends. It's not going to have anything else attached to it. It's like an airport terminal. It doesn't go anywhere else. It just stops there. It's a dead end. No outlet. Fluorine is usually another one. F is usually one that doesn't connect to anything else further. And carbon usually forms a chain of carbon, 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 like that, with hydrogens all around it. But you don't have one of those here. Okay, the next step, determine the number of valence electrons associated with each atom and combine them so that you know the total number of valence electrons. Okay, so nitrogen has 5 valence electrons. I can tell because it's in column 5A. So I'm going to go up here and I'm going to say nitrogen, I've got 1 of them, and it's got 5 valence electrons. So that's 5 valence electrons for nitrogen. Hydrogen, well, I have 4 hydrogens, and it's in column 1A, so it's got 1 valence electron. 4 times 1 is 4. And then I'm going to add it up, 9. So 9 valence electrons. But one of those electrons got taken away, and that's how come this is a positive. So if this is a positive 1, I'm going to say minus 1. 9 minus 1 leaves me 8 valence electrons. Okay? All right. So then the next step is connect the central atom, that's the middle of my flower, to each of the surrounding atoms with single bonds. So I'm connecting the petals to the central part like this. And so each single bond is 2 electrons, right? So then I count them. So I go 2, 4, 6, 8. Well, that's my 8 there. So I'm done with this Lewis. Well, no, I'm not quite done with this Lewis structure. I'm just going to go ahead and read the next step because you're recording this. Place electrons as lone pairs around the terminal atoms, that's these at the end, to complete the octet for each. But we didn't have any left over. We used up our 8 with this. And then you check to see if the octet rule is satisfied for each of your elements. So for nitrogen, what I do is I leave my pencil above in the air, but I do a little circle and I count every time I pass one of these lines. So I go 2, 4, 6, 8. 8 valence electrons, so it's octet happy. Hydrogen only needs 2. 2, it's octet happy. 2, it's octet happy. 2, it's octet happy. 2, it's octet happy. So these guys are all octet happy. Then the next step is, after you're satisfied with the Lewis structure you've constructed, perform a final electron count. So 2, 4, 6, 8. That matches my 8 here. So I'm good. Now, because this has a +1, because it has a charge at all, whether it's positive or negative, I draw a bracket around it, and then I put the charge outside. And so now I'm done with that Lewis structure.
I have a question.
Yes.
So, since he put the I know you just put the lines, but he put the dots.
Oh, he put the dots. 2 dots equals a line.
Okay.
I should have paid more attention.
That's
and done
okay.
that.
I just was wanting to make sure.
Well, I'm going to do the next one.
Okay.
And we've got 3 minutes. Okay, I'm going to do the next one, and I'm going to do dots.
Okay.
Because that one's more complicated.
Okay.
Are you ready?
I'm ready.
All right, so we've got SO42 negative. Step 1, do the skeletal bit. Okay, so S is the middle of my daisy, and then I've got oxygen, 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 right? Step 2, count up my valence electrons. Well, I've got sulfur and oxygen. I've got 1 sulfur, 4 oxygens. Sulfur is in 6A, so it's got 6 valence electrons. Oxygen's in 6A, so it's got 6 valence electrons. So I multiply, and then I add, and then this says -2, so I'm going to add 2, so that's 32 valence electrons that I need to find a place for. Next step, connect my central atom to my terminal ones, so 2, 4, 6, 8. So that's 8 out of 32. Oh, I did lines again. I'm so used to doing lines. I almost forgot how to do that. Okay, so 2, 4, 6, 8. Okay, so now for the rest of them, I put them as lone pairs around here. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. 32. Okay. My next step is look to see if I'm octet happy. Okay, so sulfur. 2, 4, 6, 8. Octet happy. 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 So I'm all octet happy. Last step, do a final electron count. And the reason they say this is because sometimes you have to erase and move electrons and stuff. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. That matches my 32. Because I've got this charge here, I'm going to do my bracket and my 2 negative. These are too easy. I need a hard one.